students. Today I am going to explain forced vibrations. This is very important question for first semester BSc students for physics. Here, forced vibrations. As we know that each and every body has its own frequency called as the natural frequency. But when we apply the force on the body to vibrate, then the body vibrates other than its natural frequency, so that these vibrations are called as forced vibrations. For suppose, see this definition. Under the external periodic force, a body vibrates with a frequency other than its natural frequency, called forced vibrations, and the body is said to be in forced vibrations. For example, a small piece of any body put on any vibrating body, then that small piece of a body vibrates other than its natural frequency. So this is the example for forced vibration. That is, the body vibrates not as its own frequency, they call as natural frequency. It vibrates the frequency of vibrating body. That is, the body is said to be in forced vibrations. Here see this. Simple harmonic oscillator vibrate with a periodic external force at any given instant of time. Due to this periodic force, three forces are acting on the oscillator. As we know that in previous case, a simple harmonic oscillator just pulled from its mean position and then released it, so oscillate to and fro about mean position. Here, for suppose this simple harmonic oscillator vibrates under the periodic force. So then what happened? Their amplitude of the simple harmonic oscillator. Here we are applying a periodic force. See this. Here when we are applying a periodic external force on a simple harmonic oscillator, there will be three forces acting on the oscillator to oppose the motion of a simple harmonic oscillator. Here see this. There are three types of forces opposing the motion of the oscillator. Here one is restoring force. This is here restoring force is equals to minus kx, where k is a proportionality constant, and also frictional force is equals to minus r into dx by dt, as we know that dx by dt is v. And then periodic force is equals to capital F into sine pt. Here p is the frequency, that is periodic frequency of applying force we are applying. Here see this. Here frictional force is equals to minus r into dx by dt, means minus r into v. That is, the friction force increases as the velocity of the oscillator increases in opposite direction. So that here the total forces acting on the body can be written as, here F is equals to minus kx minus r into dx by dt plus F into sine pt. These are the three forces acting simultaneously on the simple harmonic body. Now what happened? Due to all these forces, body get accelerated, so that we have to apply Newton's law, that is F is equals to ma. Here as we know that F is equals to ma, and putting here in this equation, ma is equals to minus kx minus r into dx by dt plus F into sine pt. Here see this, just here this capital M, this small m I taken capital M into d square x by dt square, that is the acceleration is also known as d square x by dt square plus r into dx by dt plus kx is equals to F into sine pt. Now dividing this equation throughout with m, then we get d square x by dt square plus r by m into dx by dt plus k by m into x is equals to capital F by capital M into sine pt. Here you should understand, just I written here in place of capital M I wrote here small m. Understand this one, this is a small m, and then Next, see this. Let we are going to consider R by M is equals to 2B. This is a constant. Already I explained in damped harmonic oscillator. If you have any doubt or see that video, then you get the clear idea about this damping constant. R by M is equals to 2B, and K by M is equals to omega square, and F by M is equals to small f. That is, force per unit mass is taken as a small f. Here further, next equation we are going to this one as, see this. After substituting these values, we are getting d square x by dt square plus 2b into dx by dt plus omega square x is equals to f sin pt. Here, this equation known as the differential equation for forced oscillator. Here, up to this one, it is very important for short answer. Here now we are going to know about the solution of this forced oscillator. We have to consider, let x is equals to a sin pt minus theta. As we know that p is a periodic frequency. Here see this, a is equals to amplitude, p is equals to frequency of forced vibration, theta is equals to phase angle. Now differentiate this x. What happened? We are getting dx by dt with respect to time we are doing, so that sin theta becomes cos theta. Here theta means pt minus theta. And then next derivation of this dx by dt, we are getting d square x by dt square is equals to minus a p square into sin pt minus theta. And then see this. Now these equations, that is equation 4, 5, 6 equations, put in equation 3, then what we get? Here see this, d square x by dt square plus 2b into dx by dt plus omega square x is equals to f sin pt. This is equation 3. Now we are going to substitute the differentiated values. Minus ap square sin pt minus theta plus 2b ap cos pt minus theta plus omega square a sin pt minus theta is equals to f sin pt. Here just we are remaking this one, that is f sin theta in right hand side. See this, that f sin pt is written as f sin pt minus theta plus theta. Then what happened when minus theta plus theta cancel? We are getting f sin theta sin pt only. Here see this. Now the above equation seems to be as sine of a plus b. The sine of a plus b formula seems to be sine a cos b plus cos a sine b. Here expand this one by using this formula. We are getting f of sine pt minus theta plus into cos theta plus cos pt minus theta into sine theta. Now see this. Now this right hand side terms and left hand side terms compare. Then what happened? Here see this first one, sin pt minus theta into cos theta, and cos pt minus theta terms we are comparing. Then what we are getting? Here see this. In this case we got a minus ap square plus omega square a is equals to f cos theta. Here see this, where it is. Here see this is the sin pt minus term. We have what? Minus ap square, and then here see this, this one we are comparing sin pt minus theta into cos theta terms. Here what we got, this one, see this, sin pt minus theta, we have minus ap square, and then plus omega square a. Here see this, sin pt minus theta, then this is the coefficient omega square a is equals to, in this right hand term side we have what? Sin pt minus theta comparing, so we remaining what? F cos theta. Here this is f cos theta. Similarly we are going to be compare cos pt minus theta. Here in this cos pt minus theta we have f sin theta in the right hand side equation, and then next in left hand side equation we are comparing, that is cos pt minus theta. Where is cos pt minus theta? Here in this cos pt minus theta we have coefficient 2b ap. Here see this, 2b ap, and no term in the left hand side, that is cos pt minus theta term, so that this is 2b ap in left hand side and f sin theta in right hand side. Here these are the two terms. that is equation 8 and equation 9. See this, from minus ap square plus omega square a is equals to f cos theta, just we are common a and then write omega square minus p square into a f cos theta, and then next one 2b ap is equals to f sin theta. Just what we are doing, just comparing the term sin pt minus theta and cos pt minus theta on both left and right hand side. Here from this what we are getting, so after comparing we are going to this one as squaring and adding on both sides of the equation 8 and 9. Then we get what, a square omega square minus p square whole square plus 4b square a square p square is equals to f square. See this here, see this equation, just this equation, see this equation 8 is squared, that is a square omega square minus p square whole square, and then add with the 9, that is 4b square a square p square. This is the left hand side, and the remaining right hand side here f square cos square theta f square sin square theta. As we know that sin square theta plus cos square theta is equals to 1, then we have right hand side only f. That is what we got here, that is a square of omega square minus p square whole square plus 4b square a square p square is equals to f square. Here from this we want amplitude, that is a is equals to f by square root of omega square minus p square plus 4b square p square. Here this is the amplitude equation what we got. Here this equation 10 gives the amplitude of the particle. Here this equation, substitute in equation 4, we get displacement. What is equation 4? Here see this is the equation 4. Here see this, x is equals to a sin pt minus theta. Just now we have to substitute the a value in this equation, then you get the value of displacement. Here see this, x is equals to f divided by square root of omega square minus p square whole square plus 4b square p square into sin pt minus theta. Here this is a very important question, forced oscillator or forced vibration, and I hope you understand very well this answer. If you have any doubt, please ask in comment section, I will clarify. Thank you one and all.